words in which trigonometry is coming from. We have the trigonon and metria, right? Now, trigonon in Greek simply means triangle, and metria is what measurement. Okay, so in short, when we talk about trigonometry, we are talking about triangle measurement. So at the end of the lesson, you should be able to measure any triangle of any magnitude, right? You should be able to find angles of any triangle, and also the size of any triangle which will be given. You should be able to find the size and the angles involved. Right? Now, when you come to trigonometry, we have three basic ratios. In trigonometry, we have three basic ratios. And these ratios are so the basic ratios that we have in trigonometry are sine, cosine, and tangent. Right? So for the sine, if you shorten it, we call it, we make it SIN in short. So for sine, we can make it SIN. Cosine can be shortened as cos, right? Then we have tangent to be tan. Okay. So the short form of sine, as we have it over here, sine. Then we have cosine to cos, and that of tangent to be tan. Good. Now, let's look at this particular triangle. What kind of triangle is this? So in this triangle, you can see we have the right angle at this point. Okay. So basically, we have a right angle. This is a right angle, right? Right angle. Then we have the upper side being added, or the other side being joined together. So in this case, we are having a right angled triangle over here. Okay, so with this right angled triangle, it's going to help us in this trigonometry. Okay, so now if you take this right angle triangle, we have about three sides over here. You can label them as A, B, C. Right? So as I stated earlier, this is a right angle. So when you join the other side, then it becomes a right angle triangle. Okay. So when the right angle triangle is drawn, you realize that there's only one side. This particular side is always opposite to the right angle. Okay. So the side which is always opposite to the right angle is what we term as the side which is always opposite to the right angle is what we term as well the hypotenuse, known as the hypotenuse. Now, with this other side, the two sides over here, in terms of this particular shape, it will be difficult for you to identify this other side. Okay, this other sides can be found when there's an angle being indicated, either in this side or this side. Without the angle being indicated, to just identify the side will become a problem. But for hypotenuse, there's no controversies about it. Hypotenuse is always opposite to the right angle. Now in this case, let's see and put, let's say, theta at this point. When we put theta over here, then we can say that the side which is opposite to angle theta, we have AC. Okay, AC, side AC is opposite to angle theta. And therefore, this side becomes opposite. So we name it as opposite over here. Opposite. Because it is opposite to angle theta. Then the side which where angle theta has linked itself. Okay, so you see this side, it's more or less like angle theta has linked itself. And this side is what we term as adjacent. Adjacent. Now, one thing to take note of. If we interchange or if we change the position of theta, if we put theta here, then these two sides will change. Automatically, we are going to have the side opposite to angle theta over here will be A, and that of adjacent will come to this side. So that is why these two sides, we can't just predict it unless theta has been indicated. Okay, good. Now, with this our shape, let's look at one sine takes angle theta. Okay, we said these items are the basic ratios of training. And in fact, when we say ratio, then we are talking about one thing dividing the other. So if sine is representing a ratio, or if sine is a ratio, then it is representing something over something. Okay. So let's look at that particular ratio system. So we have sine theta. When sine takes angle theta over here, then we say that it produces opposite out of hypotenuse. When sine takes angle theta, we say it produces opposite over hypotenuse from this shape. In the same manner, when cos takes angle theta, it produces a ratio which is adjacent out of hypotenuse. So when sine takes angle theta, we have opposite over hypotenuse. When cos takes angle theta, we have adjacent over hypotenuse. In the same manner, when tan takes angle theta, we have opposite out of adjacent. So these are the three ratios, or the three basic ratios of training. So these items are very important. Sin theta equals opposite over hypotenuse, cos theta equals adjacent over hypotenuse. Then tan theta equals opposite over adjacent. These items are very important, and you have to remember these items. So to easily remember these, if you take, let's take the initials over here. So for the sin theta, we can take the initials. So sin, we have S over there, S here. Then let's take the numerator over here, which is opposite the initial. We have O. Let's take the denominator as H. Okay. Let's do same for cos. Cos 2, we can take the initials. So cos, we have C. We have A over here. Then we have H. So cos theta equals adjacent over hypotenuse. Then also we have T O A. So because these formulas are very important, these ratios are very important, we need to remember them. We need to remember them. And to easily remember these formulas, we take the initials out. And this is what we have as so capital. So represents sin theta equals opposite over hypotenuse. Then K, which is cos, represents cos theta equals adjacent over hypotenuse. Then tan theta equals opposite over adjacent. So for you to easily remember these formulas, you can use these shortcuts, as you can see them over here, which is so capital. Okay. So this is what we have. Now, in terms of from this shape again, it's a right angle triangle. From this shape again, I think we have another theorem that we have to talk about, which is also very important. Okay. And this theorem is what the Pythagorean theorem, the Pythagoras theorem, right? So with the theorem, Pythagoras is saying that when you have a right angle triangle in this form, Pythagoras is saying that the hypotenuse square is always equal to so from this same right angle triangle, Pythagoras theorem is saying that hypotenuse square is always equal to adjacent square plus opposite square. So in short, we can use the initials to rewrite this thing as h squared equals a squared plus o squared, right? Addition is commutative, and therefore each of them, we can interchange them and they won't be any problem. So this is what Pythagoras theorem is saying. Hypotenuse square is always equal to adjacent square plus opposite square. This particular theory is very important when it comes to trigonometry. When it comes to programs involving trig. Okay, so we need to get note of these ones, as well as the basic ratios. As time goes on, we generate additional ratios as we go on. So in this case, let's put this one over here. We know the Pythagorean theorem now, hypotenuse square equals adjacent square plus opposite squares. We also know of the basic ratios, sine, cosine, and tangent. And when sine takes angle theta, we know it produces what? Opposite of hypotenuse. And when cos takes angle theta, it produces what? Adjacent of hypotenuse. And tan, when tan takes angle theta, it produces opposite of adjacent. Always remember, the hypotenuse side is always opposite to the right angle. Always. But as for the adjacent and opposite, it depends on where angle theta will be. Okay? And theta, the angle is not always theta. It can be any variable of our choice. It can either be theta, lambda, beta, all the letters and symbols, we can use them to represent the angle. But here we are using angle theta over here. So before angle theta is introduced, or unless we introduce angle theta, we can't find the opposite and adjacent. Let's take note of that. Now, let's quickly look at our complete revolution. This is a complete circle, and we know that the angle or the size of a complete circle is 360 degrees, right? 360 degrees. Now, if this 360 degrees is divided into 4 equal parts, So here we can start you can say our 0 is here, 0 degrees. Okay. So from here to this side, 90 degrees. From 0 down to this side, we have 180 degrees. Okay. Then from 0 down to this side, we have 270 degrees. And from 0 up to this side will be 360 degrees. So we start from here and ends over there. Now, in terms of trigonometry, we measure angles in anti-clockwise direction. That is why I was moving in this direction. So we have 0 here, we move to 90 degrees, 180 degrees, 270 and 360 degrees. Because in trigonometry, we measure angles in anti-clockwise direction. Okay, so these items or these shapes over here are termed as quadrant. Okay, quadrant in the sense that it has been divided into 4. of a quad. So we have quadrant over here. So here, we start from this section. This is our first quadrant. This side becomes our second quadrant. Here is our third quadrant. And here is our fourth quadrant. Now, in terms of these quadrants, okay, when we bring our basic ratios here, we say that in the first quadrant, all the three basic ratios are positive. Okay, all the three basic ratios are positive. So meaning that here our sine is positive, cos positive, tan positive. So in the first quadrant, all our three ratios are positive. So here is our first. Here's our first quadrant, and all the basic ratios are positive. Okay, then let's come to the second quadrant. So over here, you can make your, you can practice, you can test it and see. When we say in the first quadrant, all the three basic ratios are positive. You can take any angle of your choice from 0 degrees to 90 degrees, and find sine of it, cos of it, and tan of it. Okay, so from 0 degrees to 90 degrees, let's say you can take angle, let's say 30 degrees, because 30 degrees is between 0 and 90 degrees. So if we point sine 30 degrees, you should get positive answer. And if we point cos 30 degrees, also we have to get a positive answer. As well as if we point tan 30 degrees, it should give us a positive answer. That's why we are saying that in the first quadrant, all the three ratios are positive. Okay, now let's come to the second quadrant. In the second quadrant over here we have our second quadrant. Our second quadrant. In the second quadrant, we say only sine is positive, cos is negative, and tan is negative. In the second quadrant, we say only sine is positive, cos is negative, tan is negative. Now we can also test it by taking any angle between 90 degrees and 180 degrees. Say 100 degrees, right? You can punch it on your calculator, sine 100 degrees, and it should give you a positive answer. Cos 100 degrees should give you a negative answer, and tan 100 degrees should give you a negative answer. And these things, there are reasons for it, and as time goes on, we will talk about that one. Then when we come to the third quadrant, we say tan is positive, sine is negative, cos is negative. So in the third quadrant, it's only tan which is positive. So you can also choose any angle between 180 degrees and 270 degrees. Say 200 degrees. And point tan 200 degrees. It should give you a positive answer. Sine 200 should give you a negative answer. As well as cos 200 should give you a negative answer. So in the fourth quadrant, your guess is as good as mine. It's only cos which is also what? Positive over here. Okay, cos is positive, tan is negative, and sine is negative over here. So in the fourth quadrant, so here we have our third quadrant over here, which is third quadrant. Then here we have our fourth quadrant. So in the fourth quadrant, we say cos, only cos is positive, tan is negative, and that of sine also negative. So as you can see over here, so as I indicated earlier, in trigonometry we measure angles in the anti-clockwise direction. When you start moving in the clockwise direction, we say you are measuring the angles in the negative form. Okay, so if you move in clockwise, then you'll be measuring the angles in negative 4. But if you want it in positive 4, we move in what anti-clockwise direction. Okay. Now, let's take note of these items. Whatever we are doing here, these are the basic things to know when it comes to trigonometry. For you to love trigonometry very much, then it means you have to understand these things. These are the concepts that you have to understand so that trigonometry can be part and parcel of you. So as we have over here, so you know that the first quadrant, all the trig ratios are, basic trig ratios are positive. Second quadrant, only sign is positive. Then the third quadrant, only tan is positive, and that of fourth quadrant, only cos is positive. Okay. These items are very important. As we move on, you appreciate the reason why we have these items in the system, or why we are interested in these items. Now, because they are very important, we need to be able to remember them easily. Okay, so that when you encounter any problem, it won't be a problem because you understand the basis of the trigonometry. Okay, so because we need to understand or have them in memory, at times we can use some shortcuts for it. Some normally use here cos is positive. Here all of them are positive. Here sine is positive, and here tan is positive. Then they shorten it as cast, right? Cast. For them to remember it fast. So that they know that in the fourth quadrant, cos is positive. In the first quadrant, all of them are positive. In the second quadrant, sine is positive. And in the fourth quadrant, tan is positive. But this particular one, if you don't take care, you might represent the first quadrant to be cos. Okay? If you don't take care, if you use this and you are not much careful, you might use cos to represent the first quadrant, which will be a big problem. So I would prefer to use all silly term cards, right? All silly term cards. All represent all of them in the first quadrant. All of them are positive. Silly represent the second quadrant, which is sine is positive, and term, third quadrant, tan is positive, cat, cos is positive in the fourth quadrant. And I think this one moves with the direction of this quadrant, right? It goes with them because all start from the first quadrant, silly, sine in the second quadrant, tan, term in the third quadrant, and cat in the fourth quadrant, right? So all silly term. But any of them, if you can choose any of them and use them. Okay. Now, let's understand something over here. You could see that 0 degrees and 90 degrees, all of them in the first quadrant, is a range between 0 degrees and 90 degrees. Okay, so we can rewrite it mathematically as 0 degrees less than or equals to, let's use our theta, and theta less than or equals to 90 degrees to represent the first quadrant. If you want to use the range to represent quadrants, then in the first quadrant, 0 degrees less than or equals to theta, theta less than or equals to 90 degrees should represent our first quadrant. So in many cases in examination, they will give you the range. Where theta, where x, where y, where p is between 0 degrees and 90 degrees. And that should tell you that they are saying that the angle theta or p or x or whatever they are talking about is in the first quadrant. Okay, and remember that in the first quadrant, all ratios are positive. Then in the second quadrant, we can have a range to represent it. We can have 90 degrees less than or equals to theta, theta less than or equals to 180 degrees. Okay, so in place of second quadrant, we can use a range of 90 degrees less than or equals to theta, theta less than or equals to 180 degrees to represent that section 2. So when you can, in the same manner, if you come to the third quadrant, you can use 180 degrees less than equals to theta, theta less than equals to 270 degrees. Okay. Theta can be changed depending on the question, right? Any variable can be used to represent theta. And it doesn't matter, it doesn't change anything. It follows the same procedure. In the same manner, we can write the range for the fourth quadrant, which is 270 degrees, less than or equals to theta, theta less than or equals to 360 degrees. Okay? So these are the ranges for the quadrant. Okay, the range for the quadrant. Now you can see that angles between 0 and 90 degrees, we also have another name for it. What other name can we give to angles between 0 and 90 degrees? We have them to do what? Acute angles, right? Acute angles. So in place of the first quadrant, you can use a range of 0 degrees less than equals to theta, theta less than equals to 90 degrees. Or we can also use acute angle to represent it. So some programs may present the question as where theta is acute, or where x is acute, or where whatever variable you want to use is an acute. So immediately you see acute, then it means it is in the first quadrant. Okay, so we have to apply the first quadrant principle over there. Acute means the first quadrant. And all the basic trig ratios are positive. So in the second quadrant, we have what? Obtuse angles, right? Angles between 90 degrees to 180 degrees. Obtuse angle. Then we have reflex angles and everything. Okay. So this is what we have over here with the circle and its particulars. Now, for you to learn trigonometry, you need to understand these concepts, right? And these are the basic concepts that you have to understand when it comes to trigonometry. Okay? From this point, where we know that when we talk about trigonometry, we are talking about triangle measurement. And the Pythagorean theorem is saying that hypotenuse squared equals adjacent squared plus opposite squared, which has been shortened as a squared equals a squared plus o squared. Okay. And also, we also realize that we have the basic ratios in trigonometry, which are the sine, cosine, and tangent, right? Well, these are the short forms, okay? And you can see these ones on your calculators, okay? So when you have a right angle triangle, we said hypotenuse is always opposite to that of the right angle, okay? And for opposite and adjacent, they alternate, depending on what? Where the angle theta will be, either angle theta or whatever variable they will use for your angle. If the angle is here, then opposite will come here, adjacent will come here. If the angle is here, then you have the opposite here, adjacent here, in that manner. Now, when sine takes angle theta, we said it produces what? Opposite over hypotenuse. And when cos takes angle theta, it produces adjacent over hypotenuse. Then, when tan takes angle theta, it produces opposite over adjacent. And if you take the initials, right, that's where we have the SOHCAHTOA. Sine equals opposite over hypotenuse, cos equals adjacent over hypotenuse, and that of tan equals opposite over adjacent. Okay? So we need to take note of these items very well. As we proceed, you appreciate the reason why we are using these shortcuts to help us. Then if you take the circle, a complete revolution is given as 360 degrees. When you divide it into 4 equal parts, we have them to be in quadrants, right? And we are saying that the first quadrant, all the basic ratios are positive in the first quadrant. Only sine is positive in the second quadrant. Only tan is positive in the third quadrant, and that of the fourth quadrant, only cos is positive. Okay? We start measuring the angle from here, 0 degrees to 90, to 180, to 270, to 360 again. In trig, we measure in anti-clockwise direction. If we are measuring in positive form, anti-clockwise direction. If you move in clockwise, then you are moving in the negative direction. Okay, so you can see that the measurement of trig is a little bit different from that of the bearing, right? In bearing, you move in clockwise direction. But for trig, you move in anti-clockwise direction. In the first quadrant, the range of the first quadrant is 0 less than equals to theta, theta less than equals to 90 degrees. The second quadrant is 90 degrees, less than equals to theta, theta less than equals to 180 degrees. And the third quadrant is 180 degrees, less than equals to theta, theta less than equals to 270 degrees. As well as the fourth quadrant, which is 270 degrees, less than equals to theta, theta less than equals to 360 degrees. Okay. So this is what you have basically. Okay. Just go home and master yourself on these basic ones. So the next time we meet, you look at how to identify other trig identities. So we are going to look at how to generate some of the trig identities and how to prove some of them. Okay, so let's call it a day.